Good afternoon. Welcome to today's lesson on sections 4.1 to 4.2. Both these sections are on graphs of quadratic functions. I figured I should consolidate these two sections since they do talk about the same thing, but they kind of give you different formats. So I'm just going to do 3 examples. Hopefully it takes about 10 minutes. And then we'll do some practice on this on Friday. So let's say I asked you to graph the following. Say I asked you to graph x squared plus 6x plus 8. Now this is in standard form. There's actually going to be 3 different forms. So the first will be standard form. Remember, standard form is this. And here's what we're going to do. The first step is find the vertex. Remember the vertex we called h comma k? So that's what I find. H will always equal negative b over 2a. So in this case, b is 6, so you have negative 6. A is 1, so h is negative 3. To get k, all you have to do is just plug in negative 3 into the earlier equation. Work that out, and we should get negative 1. So, pretty simple. So then we draw a coordinate plane. So here's negative 3, there's negative 1. Change up colors. Then, since a is positive, it's going to open up. And if I make a little table, let me plug in negative 2 and negative 4. If I plug in negative 2, and you work out carefully, you should get 0. If you plug in negative 4 and work it out, you should also get 0. The y values should be the same. Because of symmetry. And why do we have symmetry? X equals negative 2, negative 4 are equal distance from the vertex. So, you plot your points. And you have a graph. So, pretty basic. The vertex, again, is negative 3, negative 1. And this dashed line that I'm drawing right now is called the axis of symmetry. Cuts it in half. And that equation is going to be x equals negative 3. Says it crosses the x-axis at negative 3. Let's look at this next example. Number 2. So for example 2, let's graph the following. Y equals negative x minus 2 squared
plus 3. Now this one is now called vertex form, which is very similar to the absolute value stuff we talked about a month ago. And I said we're going to talk a lot about h and k. So h comma k, again, represents the vertex. And it also represents the shift. So y equals x squared, the most basic probability you can draw is that. Because if you were to plot points, you get 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. So anyway, so for our particular problem, our vertex will be 2, 3. Here's 2, 3. It says a is less than 0, it opens down. Because our a in this problem is going to be negative 1. According to that right there. If we make a quick table, say I plug in 1, plug in 3, so I'm choosing 2 x values on each side of the vertex, but of equal distance. You would get 2 and 2. So you're probably like that. And by the way, these are called parabolas. So you have x equals 2 as the axis of symmetry. And the coordinates are 2, 3 for your vertex. The last example I'll do will be a graph that's in intercept form. So this one is called intercept form. Which is y equals a x minus p, x minus q. P and q are the x-intercepts. It's a rare form because not all graphs or functions tend to follow this. So, yeah, because some graphs may never touch the x-axis, or may touch only once. So it's not a form that's used often, but if you see it, you should recognize it's intercept form. Plus, it's already factored. So we know that the x-intercepts for this particular function will be 1 and 5. Because remember, when y equals 0, the graph crosses the x-axis. And 1 and 5 will make y 0 if you plug 1 in from here to there. Or if you plug 5 in, it would make that 0. So very simple. You locate 1 and 5. 1, 2, 3, 4, 5. So you want to graph your intercepts. And then here's the thing. h is going to equal 3 since it's halfway between the x-intercepts. So that's how you find h for this format. It's going to be p plus q divided by 2, kind of like the average. So in k, you have 2, 3 minus 1, 3 minus 5. You get negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. So locate 3, negative 8. And again, I just plugged in 3 for x into my original equation. And voila. There you have your parabola. Vertex 3, negative 8. Axis symmetry is x equals 3. So you've seen how to graph all 3 types of quadratic functions. So you'll have a chance to practice this tomorrow. So as I promised, only 3 examples. Hopefully the video comes out to 10 to 15 minutes. So it should be manageable. And I'll see you guys tomorrow.